So in the previous video, I gave you a very brief introduction on what radians are and how we're going to be using them. But in this video, we're going to actually get into some of the content, how we can find a radian, and of course converting between degrees and radians, which is going to be very important for the rest of second year A-level maths. So what I have in front of me, as you can see, is a circle. Now this circle has a radius of 1 and an arc length of 1. So the radius and the arc length are going to be equal. Now it doesn't really matter what the radius is. It could be 6, it could be r, it could be 100, it can be whatever you want. Just as long as it's equal to the arc length, that's what matters. So if you're feeling comfortable, you can just use r as being whatever you want. But in this case, I'm going to choose it as 1. Now, the question is, can we find what the angle is made when we have an arc length of 1 and a radius of 1? And the answer is yes. So if you remember back to GCSE, the length of an arc is going to be L equals 2 pi times the radius multiplied by theta, the angle, in degrees, over 360 degrees. Now we know that the arc length is 1 and the radius is 1, so we can actually substitute both of these in to find the angle. So arc length can be 1, and it's going to be equal to 2 pi times 1, which is just 2 pi, multiplied by the angle over 360. And so now we can actually rearrange this to find the angle. So I'm going to start off by just crossing this out, simplifying it as 1 and then 180. And so therefore we've got 1 equals pi theta over 180. And then from here we can multiply both sides by 180 over pi, which will give us theta is equal to 180 over pi. Sorry, it's a bit out of it might be a confusing thinking yourself, what does any of this mean? What this ultimately means is that 1 radian is equal to 180 over pi. So that's the main thing you need to remember. 1 radian is going to be equal to 180 over pi. Now you don't really need to know, you can put that into your calculator. It'll give you something like, I'll have a look now. So if you put that into your calculator, it will give you this, so 57.29, so that doesn't really matter, we're not interested in that, just as long as you can remember that 1 radian is equal to 180 over pi. Now the question is, can we adapt this to half a circle, so 180 degrees, and a full circle of 360 degrees? And the answer is, again, yes we can. So we're going to do this in the same method as we did last time, by using the length of an arc formula. And I'm going to draw a circle as best as I can. That's not very good, actually that's not very good. Try and draw this as best as I can, so that'll do. I'm gonna give that a length of, a radius of 1. Again, doesn't really matter, it can be 6, or it could be 100, it doesn't really matter. I'm gonna give this the angle of 180, because that's what we know, so this is 180 degrees. And we're gonna use the exact same thing, just this time instead of finding the angle, we're gonna find the arc length. So, remember the formula, L equals 2 pi r times theta over 360. So we know the radius is 1, and we know the angle is 180. So this can be rewritten as 2 pi times by 180 over 360. And then we can simplify this to a half. So this is going to therefore be 2 pi times by a half, which is equal to just pi. And so what this therefore means is that 180 degrees is going to be equal to pi radians. And this is probably the more important. I think 1 radian is equal to 180 over pi is a bit less important than this, which is going to be super important, and you need to absolutely remember this. And so now, can we adapt this to the whole circle? And again, yes we can, but this time it's going to be a lot easier, because all we need to do is multiply both sides by 2, so that we get 360 degrees is equal to 2 pi radians. And so these are the two important things you need to know. 180 degrees is pi radians. 360 degrees is 2 pi radians. And this furthermore means that 90 degrees, since that's a half of 180, is going to be equal to pi over 2 radians. It might be a bit hard to see on here, but 90 degrees is pi over 2 radians. 180 degrees is pi radians. 360 degrees, 2 pi radians. And so that's absolutely something you're going to need to remember for the whole year. And you're not given any formula to convert it, unfortunately, on the formula sheet. But I do have a formula which you will be able to remember for your exams. So the way to convert it is, actually no, before I show you that, one thing that's going to be very important to remember is the unit we're going to be measuring in. So if you remember back to degrees, we were using, for example, 180 degrees is going to be 180, and we have this little circle here. So for radians, up until now I've been writing it as just radians, but we can actually rewrite this as, so let's say we had pi radians. Instead of writing pi radians each time, we can actually just write pi and a little c, so kind of like half a circle. Or alternatively, you can write pi rad for short. I prefer writing pi rad, so it's just 100% clear on what we're talking about. However, either one will do. I think maybe it's easier to write pi and then the small c because it's a bit shorter, but again, it's absolutely up to you. You're going to get the marks either way. But yeah, I'm going to show you the formula now on how to convert between degrees and radians. So let's say we had 1 radian, and then we had, let's say, 180 pi, because 1 radian is equal to 180 over pi. So to get from radians to degrees, we multiply by 180 over pi, and then to get from degrees to radians, wait, I'm going to write that, we're going to multiply by pi over 180. So this is a very important conversion you need to remember. So this is degrees, and this is radians. So to convert from radians to degrees, multiply by 180 over pi to get rid of the pi, and then from degrees to radians, you're going to multiply by pi over 180 to add the pi to the radians. And so it's a very good idea that you take note of this formula, because it's going to be very easy for you to remember how to convert between the two. Now, one thing that's very important to remember is that you'll sometimes get radians as being quite nice and convenient. So you might get, for example, pi over 2 radians. You might get pi radians. You might get 2 pi radians. And this is, of course, very nice, because this is 90 degrees, this is 180, and this is 360. However, in some cases, you might not get this. Sometimes you might get something like 0.3085721 something like that on your calculator. And so don't be kind of freaked out by that. So sometimes it'll be quite nice for you in this case with pi over 2 or pi, but in other cases it might be quite a nasty number like this. And another thing is it's super important to remember to round with radians. So depending on the exam board that you're using, round to the appropriate significant figures. So if you're using an exam board which rounds to 3 significant figures, then do it to 3 significant figures. So in this case, it would be 0.309 because that's 3 sig fig now. So just remember to always do that, and the same rules will apply to radians. Now, as an example, I'll give you an example of converting between degrees and radians. So let's say we had 60 degrees and we wanted to convert that to radians. So remember, for this one, we're going to multiply it by pi over 180. And so then we can cross this out, multiply, and this gives us 3. So this therefore means that this is equal to pi 3 radians. So 60 degrees is pi 3 radians, and we do that by multiplying by pi over 180. Now let's say we wanted to do the opposite. So let's say we had pi over 4 radians, and we wanted to write that in degrees. So remember, for this one, for converting between radians to degrees, we multiply by 180 over pi to get rid of the pi. So we're going to cross the pi's out, and then we're just left with 180 over 4, which we can then simplify to 90 over 2, and then we can simplify again to 45 degrees. So yeah, that is how you convert between radians and degrees, and also remember to round it to the appropriate significant figures always when you're doing radians. Thanks for watching.